In the previous video, we talked about why TSMC became one of the most important companies in the world. They manufacture the chips designed by companies like Nvidia and Apple.
That episode was honestly kind of scary. The whole world depending on one company sounded like a final boss setup.
Yeah, it really shows how concentrated the semiconductor industry has become.
But while watching that episode, I kept thinking about something. What even is a GPU in the first place? People keep saying GPU this, GPU that, but nobody explains what makes it different.
That's actually a really important question, especially now, because AI discussions almost always revolve around GPUs.
Seriously, at this point GPUs sound less like computer parts and more like mythical artifacts.
It can definitely feel that way, but GPUs didn't become important by accident. The reason is that the structure of AI workloads matched extremely well with the structure of GPUs.
So, the AI boom and the GPU boom are connected?
Exactly. And to understand that, we first need to understand the difference between CPU, GPU, and ASIC. Today we're going to break down what each of them actually does, and why GPUs became the center of the AI industry.
This feels like one of those everything finally makes sense episodes.
That's the goal. Once you understand this structure, AI semiconductor news becomes much easier to follow. Let's start with the CPU. The CPU is basically the central controller of a computer.
The brain, right?
That's the common explanation. Yeah, it handles things like opening apps, managing the operating system, running games, and controlling overall system behavior. It's the general manager of the computer.
So it's kind of an all-rounder.
Exactly. The biggest strength of a CPU is flexibility. It can quickly switch tasks, make decisions, and handle complicated instructions.
So it's like an ultra-competent office worker who somehow does everything.
That's actually a pretty good analogy. But there's an important limitation here.
Uh-oh, there's always a catch.
CPUs are great at handling small numbers of complicated tasks, but they're not especially good at doing millions of simple tasks simultaneously.
So, making a genius engineer do endless repetitive copy work is kind of inefficient.
Exactly. A CPU is like a small team of highly skilled craftsmen. Each one is extremely capable, but there aren't that many of them. That makes CPUs excellent for complex decision-making. But if you suddenly say, please repeat this exact calculation 1 million times, that's where things become inefficient.
And that's where GPUs enter the story.
Exactly right. Now let's move on to GPUs. Originally, GPUs were developed for graphics processing.
So, video games?
Exactly. Especially 3D games. Rendering 3D graphics requires enormous amounts of calculations happening at the same time. Lighting, shadows, textures, character movement, and physics. All of those calculations need to happen simultaneously.
So games were secretly forcing computers into brutal overtime shifts this whole time.
Pretty much. And here's the key point. A lot of those graphics calculations are very repetitive. So, instead of building a few extremely flexible cores, like CPUs, GPUs evolved in a different direction. They evolved to perform huge numbers of calculations in parallel.
So, CPUs and GPUs basically grew up differently.
That's a good way to put it. If a CPU is 8 genius craftsmen, then a GPU is more like 10,000 workers doing tasks simultaneously.
So GPUs win through sheer numbers. They're the industrial revolution of computing.
That's actually a really accurate comparison. Each individual GPU core is less flexible than a CPU core, but GPUs are incredibly powerful at repeating the same operation over and over in parallel. For example, perform this calculation 1 million times simultaneously. That's exactly the kind of workload GPUs excel at.
And that sounds suspiciously similar to AI workloads.
Exactly. That's the reason GPUs suddenly became the center of the AI world. Now we've reached the core of today's topic. Why did GPUs suddenly become the stars of the AI era?
Yeah, seriously. Every AI headline sounds like more GPUs, GPU shortage, everyone panic.
That's pretty accurate, honestly. But to understand why, we need to look at what AI is actually doing internally.
I thought AI was doing some futuristic robot brain magic.
It looks that way from the outside, but internally, AI is surprisingly repetitive. At its core, modern AI mainly performs huge amounts of multiplication and addition.
Wait, really? So AI is basically a giant math gym?
That's honestly not a bad description. For example, models like ChatGPT contain hundreds of billions of parameters. Training and running those models requires repeating similar calculations over and over again.
So instead of thinking, it's more like calculate faster. Again.
Pretty much. And that kind of workload happens to be perfect for GPUs. Remember earlier, CPUs are few elite craftsmen, and GPUs are huge armies of workers. AI workloads benefit much more from having thousands of workers doing calculations simultaneously.
So CPUs are like genius chefs making one perfect meal, while GPUs are giant factory kitchens making 50,000 burgers at once.
That's actually an excellent analogy. And once researchers realized this, GPUs suddenly became essential for AI development. That's why NVIDIA exploded in importance during the AI boom. And this connects directly back to our first NVIDIA episode.
Ah, yes, the green logo controls the universe episode.
Something like that. One of NVIDIA's biggest advantages wasn't just the GPU hardware itself. It was something called CUDA.
CUDA still sounds like the name of a secret sci-fi weapon.
I can kind of see that. CUDA is basically NVIDIA's software platform that makes GPUs easier to use for AI development. And this is extremely important. Because AI researchers don't just need chips. They also need development tools, libraries, framework support, and optimization software. NVIDIA spent years building that ecosystem.
So, they weren't just selling GPUs, they were selling the entire AI starter pack.
Exactly. That's why NVIDIA became so dominant. If everyone already builds their AI systems around CUDA, switching away becomes difficult.
So it's not just about raw performance anymore.
Right. The software ecosystem became a huge competitive advantage. And remember from the previous episode, NVIDIA designs the chips and TSMC manufactures them.
So the AI boom is basically powered by the NVIDIA plus TSMC combo.
That combination became the center of the modern AI industry. Now, let's talk about ASICs.
This one sounds dangerous already.
ASIC stands for Application-Specific Integrated Circuit. Basically, it means a chip designed for one very specific task.
So, unlike CPUs, it doesn't try to do everything?
Exactly. CPUs are general purpose. GPUs are optimized for massive parallel workloads. ASICs go even further. They're designed specifically for one workload only.
So, they're basically specialist monsters.
That's a good way to put it. For example, Bitcoin mining chips and Google's TPU AI accelerators are examples of ASIC-style designs. And because ASICs are specialized, they can become extremely efficient. Sometimes they outperform GPUs in both speed and power efficiency.
Wait, so ASICs are stronger than GPUs?
In some situations, yes. But there's a trade-off. ASICs are much less flexible. If workloads change or AI models evolve, ASICs can become difficult to adapt.
So, they're like characters who only know one move, but that one move is ridiculously overpowered.
That's actually very accurate. Meanwhile, GPUs are much more flexible, which is why they became the mainstream choice during the rapid evolution of AI. Now we've reached one of the most interesting parts of the story. What happens next in the AI chip industry?
Right now, it kind of feels like NVIDIA owns the entire planet.
They're definitely in a very strong position. But the other tech giants aren't just sitting still. Companies like Google, Amazon, and Microsoft are all developing their own AI chips.
So everyone's trying to escape the NVIDIA dependency arc.
That's honestly part of it. GPU shortages and rising prices became major problems during the AI boom. So, naturally, large companies started thinking, what if we build our own specialized AI chips?
The classic, fine, I'll do it myself strategy.
Exactly. And for companies operating massive cloud services, custom chips can make a lot of sense. Think about Google, for example. They run search, YouTube, cloud AI services, and massive data centers. The amount of computation they perform every day is enormous.
So even tiny efficiency improvements become a huge deal.
Exactly. And another important issue is power consumption. Modern AI systems consume huge amounts of electricity.
AI always looks futuristic and elegant, but underneath, it's basically inhaling electricity like a vacuum cleaner.
That's honestly not too far from reality. As AI expands further, the competition may shift from who has the fastest AI to also who has the most power-efficient AI.
So, the future could become GPUs versus custom ASIC armies.
That's definitely one possible direction. And behind all of this, companies like TSMC, Samsung, and Intel will continue competing to manufacture these increasingly advanced chips.
So, the entire AI race is also a semiconductor manufacturing war.
Exactly. AI is no longer just a software story anymore. It's deeply tied to chip design, manufacturing, energy, and even geopolitics. All right, let's summarize everything we covered today. First, CPUs. They're flexible, general-purpose processors designed for complex decision-making.
The elite craftsmen of computing.
Exactly. Next, GPUs. They specialize in massive parallel computation.
The giant army of workers.
And finally, ASICs. They're highly specialized chips built for specific workloads.
The overpowered one-trick characters.
That's surprisingly accurate. And because modern AI relies heavily on repeating huge numbers of calculations simultaneously, GPUs became an ideal match. NVIDIA dominated the GPU ecosystem, and TSMC became the manufacturing backbone supporting it all.
So, the AI boom isn't just about software. There's this giant hardware structure underneath everything.
Exactly. Modern AI exists because software, chip design, and semiconductor manufacturing all evolved together.
Now, every time I hear GPU shortage, I'm just going to imagine 10,000 exhausted workers collapsing at once.
That's a slightly chaotic mental image, but honestly, it's not completely wrong. That's all for today. Next time, we'll explore the difference between logic semiconductors, memory semiconductors, and analog semiconductors, and how each one fits into modern electronics.
At this point, semiconductors are starting to feel like Pokemon evolution trees.
It really is an incredibly deep world once you start digging into it. Thanks for watching today's video. See you next time.